kind of know, it said on today's module, if you were checking or paying attention to that today is forthcoming, which means that basically this day is fairly free in what I'm going to be doing. I know what I am going to be doing. For one, we're going to be looking at some of the quizzes that I wrote for previous semesters when I was doing a heavy quiz-based format as opposed to a few exams. Because what I want to get a handle on, because what I need to decide is whether I'm giving my exam next week, in basically next Friday, or am I giving it at the end of week 6? Because those have different consequences on what I need to put in the exam based on the amount of content that we cover. Okay, if I give it at the end of week 6, I'm probably going to include things about, slicing and iterating over strings. If we do it next, let me actually be clear. So the first exam, I always like to cover a few different things. I always like to cover for loops. I always like to cover turtles in my first exam. Functions depend on whether on how far the class has gotten comfortable with functions, because functions are introduced in lab 4 and 5. Okay. But at the same time, it's, that can be pushed off to a later exam, and that's also like forced. I forced that learning of functions during the homeworks from 4 on. I make it a required part of the grade that you write functions and you use them correctly. If I do it on week 6, so last semester, what happened is that I had originally planned, well, I'll tell you. Last semester, I had planned week 5. I think I had planned like Tuesday of week 5 during class last semester. And that was too soon for the students based on on how comfortable they were with for loops. I got a good idea, a good grasp of how students were doing there. And it just did not seem like a feasible option. So I pushed it to week 6, a Tuesday on week 6. But because I want to do the exams in lab, if I push the exam to week 6, right, then it's going to be week 6 and that Monday on week 7, which is a bit later than I want. But I'm perfectly willing to do that because I want to make sure that I have a good assessment of your skills. And that doesn't really, and when I give the exam doesn't matter really so much, so long as I do it before the midpoint of the term, and and I get a good, again, reflection of what your skills are supposed to, as long as I test the appropriate things. Again, that's what matters. The only concern I have is that if I push it to week 6, it kind of makes giving 3 exams a bit of an iffy kind of deal. In which case it might be better. We can see later on if it's better to drop down to 2 exams in the final rather than 3 exams in the final. I see some of you like that idea. I say that but again, this is kind of a, not so much democratic class because I need to make these decisions, but I do value your input highly because you're the people who are learning. So I don't know, do you feel like having an exam on for loops and turtles next week is too early? No? 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 Everybody feel comfortable on doing an exam next week? Okay. So we will do an exam next week. Well, next week for the people with Friday labs, it's going to be Monday for the people who have, not this Monday, but week 6 Monday. So next week is week 5. So the exam will be on, depending on when you have your lab, week 5 Friday, week 6 Monday. Make sense? Okay. I will try to give the same exam on both. I might have to vary it up because people like to chat about their exams. I please ask that you don't necessarily do that. Now, next thing we have to decide before we go on to going over the kind of questions, and I will post the practice exam basically ASAP. I will in fact do it during our lecture. The next thing we want to discuss is the format of the exam. Okay. So the way that so first off, what resources are you going to be allowed to use during the exam? And because of the questions I need to ask on the first exam, which doesn't apply to the rest of the semester, because of the questions that I need to ask on the first exam, basically what is going to be allowed is you have an open note, you have open book, you have open resources. What you cannot do is run code and write code in your editor. Why is this? Because I want to be able to ask questions that say, what is the output of this code? Does that make sense to everybody? Okay. In future, you know, those kind of questions allow me to do short questions that allow me to give you multiple choice questions that are easy to grade for those first exams. And that's kind of matters when I have all to grade. So being able to automatically grade those matters. But otherwise, it's you basically have access to any kind of resource you have that you need. The exam will be on Canvas because I know from the past, and having gone back to doing paper after doing it online for so many semesters, that doing paper in this class, never again. that was so painful. I lost. Not only that, like when I was giving them back, I felt like I lost half of the lecture just simply passing back the papers. It was not fun. So, so yeah. All right. So that means that what we will do is that I will adjust the module 6 accordingly. That means that I will go over it means prepare to do if statements on Monday, or understand how if statements work on Monday, so that we can do the blame Pope Gregory the 13th exercise, which is my leap year exercise, because it has to do with Gregorian calendar. So that's why we're blaming him. So, okay. So first off, let's go ahead and schedule that announcement. So, boom, boom, boom. Today is that. So CIS 1051 lecture, exam 1. Exam 1 will be held in lab September 17th / I believe that was the 21st. No, the 20th / 20th. Depending on when you have labs. February, of course. So, I was looking at the fall dates, so I am a bit off right now. February. Time has really become weird and not great ever since that pandemic started. Like I don't know how many years passed in 1 month. It was really weird. So depending on when you have labs, more details to follow. Practice exam, and now insert document, course document, practice. Let's see, yeah. Exam practice, that should do it. That should do it. It may have some problems in there that were, let's see that. Yes, okay. So first thing you should know. Okay. Note. Some questions like functions may be excluded. Okay. So I'm going to just simply send you what I have now. If I need to touch it up later, I will touch it up later. I just figure that you should get details on what to expect now. And on our class on Thursday, we will I will do a review session over the practice exam. I will go over I don't plan on posting the answers for the practice exam. What I plan on doing is on next Thursday, I will go over the practice exams and give you the answers then. That seems like the easiest way to do that because I can explain how you get to the answer, which is also just about variable. Okay, sorry for the disorganization, but again, it was one of those things where I wanted to do that, but I felt like I would send students, into being, I felt that students may be much less prepared. But then again, if you've had at least one semester under your belt if you're here in the spring, most likely. So that makes all the difference in the world. All right. So let's go ahead. So I'm going to go to Runestone right now, and I will go ahead and look at some of the old quizzes that I wrote. So, which unfortunately means that if I show you these, I can't use them, but they give you a good idea of the kinds of questions I love to ask. I'll also be running the grader soon on this so that once your exam is graded, you can kind of have a midway score as to how you're doing in the class. And again, once I run the grader, don't worry about it. You'll be able to still see those, still fix those up later. So quiz 2, problems. Yeah, so there we go. Yeah, these were great questions for this. Okay, so I'm going to make this easy to view on your end, and I'm going to rename this to practice problems. Whoops, practice problems from old quiz 2. Rename, and I will make it visible to students as an exercise here. Allow late submissions, remove the 45-minute time limit comment, close preview. And then let's see. Make that worth 0 points because I don't want to have to grade that one. And then let's see, make them 10. 10, so I can give you credit for doing this as an in-class exercise. Save. All right, so that should now pop up under your assignments on Runestone. Practice problems from old quiz 2. Everybody see it? So let's go. So these are some problems that I gave as kind of as a graded assessment during COVID, because proctoring during COVID was a nightmare. So what I did is I gave these as a time limit. I really couldn't proctor them as well as I could because proctoring, again, nightmare. So let's look at these kind of questions, then we'll go through them. Compute and print the following using a for loop. If you're unable to see the math equation above, it should read the sum of all numbers from 50 to 100 inclusive. I know the sigma notation is scary to some people who don't really like Greek letters, and you're totally justified in that. I feel like mathematicians sometimes just use the Greek letters to make things seem a lot more difficult than they are. Next one of my favorites are these Parsons puzzles, which are given, arrange the code below so that the shape of shown in the image is drawn. And I love Tetrimos. I love doing Tetrimos on exams and stuff like that. So here we've got the classic El Tetrimo from the second best-selling video game of all time, Tetris, right? Any takers on the first best-selling video game of all time? It used to be Tetris, but it was dethroned. Minecraft. All right. So this is pretty cool because it's got a function here. And again, I'm going to debate whether or not we include functions on the exam, but this is still a good practice here. And what you do is you take these and you drop them here, and they have different levels of indentation. So you want to get the order correct as well as the indentation correct. This one over here, this one is actually a question I've asked on exams prior to COVID as well. So this is an actual exam question, except I didn't give the code for that one, where I just simply said, give me code to draw this image that generates this image. Or I've done the reverse, where I've said, here's some code, please draw the image that appears. So those are the kinds, so that should give you an example of like, those are the kinds of the hardest level questions I like to ask during this exam, which is here, take some turtle code, either analyze it, and, draw the output, or, here is the or give, write code that generates an image and here's the image I want you to generate. And in those cases, the distances are, whatever you want them to be, in generally speaking. So if you want to make your squares 50 or 100 or 200, doesn't matter. I know that some of you might be worried about drawing during the exam. So if that's the case, on the angle, you shouldn't need a protractor. The angles I plan on using are generally 90, 45, 30, and 60. And you don't have to be to scale. They just have to be rough. In other words, the ones that you would use for triangles and squares. Okay. And then here's another one, complete the code. So complete code to do this. So let's start with the first one and let's go through this. Compute and print the following, use a for loop. So here, you hit the show code button and then you go ahead and work on this one. Obviously, you're going to want to do a for loop for this one. And I did write tests for this one, which is basically I checked for hard coding. The answer is, by the way, 3825. But as you can see, I think I should have done some hard coding in here that prevented me from going, prevented students from just doing this. There we go. Checking for hard coding. Nope. Actual value none, but then it messes the for statement check. So, oh well, we'll see. So go ahead and take a try at this one. Again, what you're trying to generate is a for loop. This is testing you on the accumulator function, right? The accumulator function, which is the sum of all numbers from 50 to 100 inclusive. And again, you're more, even though this came from a practice exam, this is not an exam, this is an in-class exercise. So feel free to, chat with the people around you, consult, help out people who are having trouble. Pause that. And pause, resume screen sharing, pause, resume recording. Okay. So what we've got here is total is equal to 0. So this is an accumulator question, right? We start an accumulator and we say, okay, we need to do a running sum. So what we want to do is add up all the numbers in the range from in this range. So for num in range we want to go from 50 to 100 inclusive. So I want to start at 50. And if I say 100 here, I'm going to get close, right? But that will go up to, but not include 100. And so I mention inclusive here. Now, if you make this mistake on an exam where you're supposed to go to inclusive and you do exclusive instead, how do you think I'm going to treat that? I'm going to mark a point off or something like that and just move on because it's not a big deal. I figure you're moving faster in an exam and that's a very, That's a very easy thing to check if you actually are running your code. And on this exam, you aren't running your code. Make sense? So that's not something to really have the biggest, to worry about if you do 50, if you forget to do 100, or even if you do this 102, because that one can easily, I just did 102 accidentally by mashing my fingers, by fat fingering it, as it's called. I accidentally hit the wrong key. So, okay. And then over here, we can do total is equal to total plus num. And then print total. Now, again, we can shorten this val. And if you wrote a code that looks something like this and gives you and passes all the checks, most likely you got this right. Okay. Let's go and so the last thing I want to mention is that, of course, as I mentioned in previous lectures, you can shorten this to total plus equals number. Run it, and there you go. Okay. So the next one is, the Parsons puzzles that you've seen in these textbooks. I'm not really going to be able to do those on Canvas, unfortunately, I don't think. Okay, I mean, Canvas has some support for it, but it's a pain. And trying to do this kind of stuff on Runestone, trying to do proctored exams on Runestone is like, ugh, it's rough, really rough. So this is good for being a textbook and for doing these kind of exercises, not so much for doing the exams, as I found out to my dismay. Now in these kind of blocks though, I put this one on top and I say first get set up. So that's obviously should go at the top, the one that says first. And then this one is second. So that kind of helps you figure out what the rest of the code should be. But again, over here in this one, the indentation does matter, and there's 3 levels of indentation for your functions and your things. And this is just the draw square function that you should be getting very familiar with at this point. All right. So go ahead and take a shot at this one, and then I will go back over it, and then I will make some more announcements with regards to what's going about the class and the exam and what's going on. More announcements that I wanted to mention, but I completely forgot because today I'm apparently Mr. Organized. Okay. So for this one, we need to drag these appropriately. So this says first get the setup. So we want to do these. Then next we want to create the command to draw square. We're creating. So remember with defs, define functions, what we're doing is that we're creating verbs to add to our programming language. I don't plan on testing, since we're doing this in week 5, I don't plan on testing this one to writing your own functions too much here, because again, with Python, fortunately, I can test you on for loops and the like without having to write functions. It's great. But I will double check to see what I have to make sure, and that's why I'm going to send out more details. So to draw a square, right, what we want to do is draw a line and turn 4 times. So everything inside the function gets indented inside the function. So for I in range 4, Bob.forward side, and then tell Bob to move forward however long we want the side to be, and then to RT, which is short for right or right turn, 90 degrees. Then we're done with the function, so we stop indenting. Then we want to draw the, let's see, that's the last command. Then we want to define the function to draw an L Tetrimo. So we need to read these, and let's see. So here we can use actually a bit of logic to note that Bob isn't shown in this picture. And over here, I've got a comment that says makes Bob hide. So this would make sense to kind of go last in this function because this would make Bob hide. We also note that this L Tetrimo is made up of 4 squares. So we need to call the draw square function 4 times. We have draw square here, and then we have a single draw square command here, and we have a for loop, which runs twice, so that means that we can use that to draw two squares if we put them together. So let's see what they would do. So for I am range this. So, and remember with the draw square and the way I try to do these functions, I try to make them so that that Bob ends up in the place he began when he draws a complete square. So that makes it easy. So if Bob's starting here on the top left, boom, 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 then he will start there, and then to move down, he would need to right turn and move down and then left turn to undo that turn. So if we do that over here, so in fact, if we do that for Bob over here, for I am range 2, we tell Bob to draw a square, which he does. Then we tell him right turn. So let me go ahead and draw that actually. Bob, draw a square. Yeah, it's a terrible square. But point being is that he's facing this way. Then we tell him to right turn 90 degrees. So now Bob is facing this way. Move forward 50 spaces. Great. Which is the distance that's being used consistently throughout this. Okay. And then left turn. So now he's facing this way. And now this activates again. So we're in this loop. We tell him to draw another square. Like I said, turn, ba-bum. And he goes down here again and then ends up turning this way. Just repeats what he did. Okay. Then so what we can do for this one is that he draws a square and then he could move forward and draw another square. And that's exactly what we do with the with this. And every time I draw with a mouse on my computer, I keep getting reminded, wait, I bought a computer with a touchscreen and a virtual pen, and I always forget about the virtual pen. And then I have to go digging through it. And there, and now I feel silly for doing that in the first place. Like I said, I'm Mr. Organized today. Okay. So draw this. And then at the end, we do the El Tetrimo. Hey, it's almost as though I knew the answer to begin with or something. All right. Now, like I said for this one, so before I move on to this one, actually, I do want to make a couple, I want to mention a couple things that I should definitely mention. First off, this weekend is a hackathon, if you have not heard. Have you heard? Yes. And some of you are like, I'm an intro student. Why should I go to a hackathon? I could barely learn anything. Actually, since you are just starting, you benefit the most because you have the most to learn from going to a hackathon. If you have the chance to be on campus on Saturday, I highly recommend just coming, even if you aren't convinced about like fully committing to participating, because you can learn stuff, you can network, you can meet people. But I mean, and if you want to try doing something, I will be around from 9 to 3 to give suggestions about what to learn and give appropriately, appropriate advice about what's targetable and what's not targetable. It's a good experience if you haven't done it before. Okay. And if you're interested in it, great. If you're not interested, stay home, get some rest. Saturday, you should definitely sleep in or something. All right. Now, the second thing I want to mention is, since I was walking around, I did get a question about the exam. I mentioned about two-stage examinations earlier this semester, right? Everybody remember that talk? So the plan is for that, since we're doing it in lab, it is for this exam to be a two-stage examination, which means that we do you take the exam, you get 70 minutes to take the exam, and then the rest of the exam, and then the second portion of the exam is done as group work. You're done, so you get into, you split into groups of 3 or 4, and you do the rest of the exam. That part of the exam is worth about 20 points. The solo portion is worth about 80 points. Now, why, and as I mentioned, the reason I do this is that it allows for immediate learning and immediate correction of material. It allows for mastery of material by teaching it from the students who get it correct. It allows for immediate correction of the material and immediate learning of this by the students who get it wrong. It's been extremely well, it was extremely well received last semester. It was a headache for me to manage, but the students really enjoyed it. So I'm planning on doing that there. So be prepared for that. You do not have to have groups pre-made. The idea for the group portion is that will be questions that are, it will either be like a selection of problems from the exam. It might be all the questions from the exam that you just took. It depends on how I want to run it. What I've done, it could also just be, questions that are similar, the same question, but with the file, with the serial numbers filed off, essentially. The point being is, though, that this group portion should not give you any stress, because the guarantee is that the group portion can only help you, it cannot hurt you, right? So if basically your group hands in an empty sheet of paper, so if you score an 80 out of 100 points on your original exam, okay, and your group hands in an empty blank sheet of paper for your group exam, then your group exam grade is now an 80 out of 100. Make sense? That is how that gets fixed. So this can only help your grade, it cannot hurt it. Okay? And so don't be worried about that. If you have a need of an accommodation through DRS, extended time or the like, we can talk about solutions that work for you, such as taking the exam earlier at an earlier day or time, and then going and doing the group portion either during the separate lab, or doing it during starting your exam early, then going into the lab and taking it there, or just, if you don't want to take the group portion, you don't have to. But there's a lot of solutions we've had in the past. Just send me an email and we can coordinate about what solution works best for you if you need an accommodation. Okay. All right. So with that, I think I've covered everything that I needed to cover. So let's go ahead and check this one out. If you haven't been already, I know that some of you have. Again, this is one that doesn't need any functions in it. And again, I've given this code to students and asked them to draw this. So as a question from an exam, I think back in 2019. So this is an actual like indicator of like difficulty of questions you would actually get on a real exam. Okay, so go ahead and take a try at it. Okay, and Zoom recording. So this one, again, fairly big. Again, when you're trying to do turtles, generally the first line, if stuff is scrambled up, is to, import the turtle and declare the turtle so you can use the turtle. I was also a big fan of making Bob be a turtle, because I mean, it's much better shape than a triangle. Okay. This is probably a very good indication of what our last command should be, the Hyde Turtle, because again, we can't see this. Now, the point to realize here is that we've got a for loop that does 4 operations. And also we have this symmetry here, 1, 2, 3, 4 identical kind of branches here. So we can kind of figure out, okay, we've got one thing we want to draw. And if we figure out how to draw this, then we can do the same thing then we can throw that in a for loop that runs 4 times. Okay. So let's go ahead and see. So the for loop starts out, and I help you by splitting it up a bit by saying for row and range 4, bob.forward. So what we do here is that we move forward, it says move forward 50. So if we're following this, then Bob moves this way, and he's facing this way, and so now we need to draw one of these branches. We've got a Bob.forward right. So we need to figure out, are we doing left or right first? And what we see over here is that we kind of see the end of doing this for loop, which is reset heading, lift up the pen, return to center, right? That feels like that comes to the end because Bob should go there. right? Oh, and then we have a Bob dot pen down, turn from the next branch. That should go after that, which is that you get ready for the next branch. So that means that these two commands go in between the forward and this one. So if we go right, we go forward. So if we did right, so if we do this left one first, it would be turn left 90 degrees. So that would go this and then turn like this. That doesn't make sense. So this one cannot go next, unless I'm horribly mistaken. Whereas if we do this one, we're facing this way, turn right 45 degrees, move backwards, forwards. And then if we do this one, Bob's facing this way. So turning 90 degrees that way turns us this way. And we can move forward. Then we would activate this, turn right 45 degrees would face me this way, reset the heading, then turn left 90 degrees. All together, we do this. And then this. Ooh, wrong order. This can be fixed by moving the highlighting. Right. There we go. Okay. Now this last one, complete the code below to draw to turn what we have from this to this. This one's again pretty nuts. This one's a very typical kind of exam question as well, where I give you some code and ask you to do something, where I say your code below, your code above, please put your code in here. And I give you something that says, here's what it looks like, here's what it is. I don't tell you where the turtle starts. That's kind of the difficulty of this one, right? That's kind of the purpose of this one, to kind of figure out which. So this is this combines both the aspect of drawing and finishing the code, because you have to draw the first bit to figure out where Bob is at the end of the code, where your turtle is at the end of the code. And then as far as drawing this top line to complete the T Tetrimo, right? Then if that's the case, then so how should you do it? And the answer is, I don't care. If it answers the question and it does it correct, if it answers the question correctly, I don't really care too much about the way you did it, no matter how overcomplicated it is, especially if it's on an electronic exam, because generally the overcomplicated questions on paper were very painful to read. On an electronic exam where you're typing up your stuff, that's way easier to deal with. So again, go ahead and try this one. And this one's nice because we get you get the ability to run this one, so we can see where he is. And he kind of ended up right here. So go ahead and take a way to do this. And there are multiple answers. There are multiple valid answers to do this one. And lastly, for those of you keeping track, I mentioned that I really like Tetrimos, and I've given these as practice problems. So Tetris. So if you want to look at, let's see, Tetris Wikipedia, here's the different Tetrimos that exist. You might want to pay attention to the ones I didn't use in practice exams and maybe make sure you can draw those. Those might show up. They might not, but they might show up. And I'm certainly not going to, there's only so many Tetrimos you can do. But I'm fans of them. Yes, that's an acceptable answer. As long as if it draws the this line, it's an acceptable answer. working on it when I was when I was going over other stuff, that's perfectly fine. Again, so what we're going to do here again is just to make sure you understand what's going on. I'm going to go ahead and comment out Bob Hyde so we can run this so that we can see where Bob is. So Bob was facing this way. So there's a couple of different ways we can do this one. I should say there's two extremely common answers I get from students for this one, both of which should work. Yeah, they should work. Okay. The first thing is we just manually move Bob to draw that top part. So we say Bob dot right 90 degrees, Bob dot forward 50, and then I just copy that and do it again. And now and there. The other way that I've seen students do this, and it's again perfectly acceptable, is that they turn right and then they call draw square again. And this works because the turtle has no problem drawing exactly on top of what he's already drawn. So Bob and 50 for a draw square function. And there we go. And then here he draws another square, which simply draws on top of what he's already drawn, but also draws the part that's missing. Both are completely valid answers. It got the job done. So by now you should definitely received an email in your email about the exam. So let's go ahead and just take a quick look at the practice exam. Again, idea. So because I do need to mention that the questions in the practice exam the practice exam is much longer than I would do for the actual exam, much longer, because the more practice, the better. And the questions are generally more difficult. So because I find for a lot of students going into their first programming exam, that as it gets closer to exam day, it gets more and more stressful. And again, I'm trying to do an accurate assessment here. It's very hard to accurately assess a student's skills if you're also extremely stressed. So I try to reduce that as much as I can. And there are some just general things, right? The points that I give out on these questions roughly correspond to the difficulty of the question. And again, the amount of space I give for things does not correspond to the difficulty of the question. It corresponds to the fact that this is on paper, and on paper I would have to give you plenty of space to write stuff. These are possibly the most important points, though, for an exam, for the exam, which is you are allowed to clarify any answer you give, and you're allowed to ask for clarification. This other one, my friend who was a PhD student that was around the same time as I did, and he taught his own courses. He would often say every question is a essay question, including the multiple choices, right? If you are making assumptions about it and you feel like they're worth mentioning, feel free to write them down. If you feel like there's something ambiguous that the professor may not have thought of, they might not have. I have had students successfully answer wrong multiple choice questions into correct answers by basically presenting their assumptions and challenging it. My ego isn't so frail to to take a challenge like that. That's I appreciate that. The things are never as complicated as they appear, especially the math, and never leave a question blank, because we can't give partial credit for blank questions. Okay. So a couple things over here, basic concept in history. This goes back to the first lecture we did, the day we went over the syllabus. Computer science is the study of computers, true or false? False? False. It's not the study of computers. And then also, there's two different questions about people here. We'll go over these on next Thursday, but keep in mind, you might want to, brush up on, some historical figures. I mentioned two specifically in my first lecture, for those of you who were there. I mentioned, I mentioned three. I mentioned Ada Lovelace, I mentioned Alan Turing, and I mentioned Al Khwarizmi, the person who algorithms are named after. These are all generally good people to know. But you'll be pleasantly surprised by that question. Okay, then I am fond of also answering these questions, and now you understand why, for at least this first exam, I do not like giving questions along the lines of, why I can't allow you to use a compiler for these questions or an interpreter, because you could just simply plug them in and get the answer, and that's, kind of easy. And again, I mentioned that these ones are much more difficult than the ones I'll give on the actual exam. This one tests you on order of operation or serves the purpose to remind you of different things. For instance, what is the order of operations of this one, now that we're using modular arithmetic? And the answer is modular arithmetic works in the same level as multiplication and division. So you treat it as such. Similarly, remember, multiplication and division work on left to right. A lot of students sometimes, confuse that, because multiplication happens first, you should do all multiplication first. No, it's left to right. And again, I'm also fond of doing things like this, where basically I null something out, where the math is overcomplicated and then becomes a zero, and then just becomes a big fat zero. Okay, you shouldn't need a calculator for any of these. I swear, because like this one you will not need a calculator for. That's your hint. Okay. I'm fond of these kind of trace the code kind of things for the first exam. These ones we didn't cover Boolean statements in this one, so this probably won't be on there. So, but at the same time, it's worthwhile to check. You should also know that I'm a bit of a troll, so it's not completely uncommon for me to do things like make all the answers to true false questions true, because that makes grading easy. Slices, similarly, we are covering slices, I think, right now in your textbook, so that I will probably, again, I plan on revisiting this exam, but I figured I wanted to send out what I had now so you had something to work with. Okay. In case chaos happens tonight. I have a 6-year-old. They're like incarnations of chaos. So, it is possible. But these turtle questions are definitely great questions for this one, where, hey, here's turtles. Draw this, where I give you Bob and 5. So 5 is length here. Draw what goes on here. Then, okay, I change it. Please tell me what happens here. That's another good thing. What makes this change significant? The other one so this gives you an idea of what the commands that I'll be using are. I use stamp. That's probably the only command that's a bit uncommon that you've had to use in lab 3 for doing the turtle clock. That's about the only one that may be a bit uncommon. And that's just simply so that I can make dots, essentially. And it makes, and those dots make it very easy for me to test for loops and things like that by making sure, did you draw the right number of dots? Complete this function. Using the draw a square function, write a turtle program. You can create more functions if you wish, right? Here I elaborate that the turtle drew 4 squares, right? There are 4 squares here that overlap. There aren't, a bunch of mini squares, that the turtle individually drew. It drew 4 squares that overlap here. Then again, another extra practice one, right here, right? You can see that I'm fond of using basic things to try to make you draw more complicated things. Confundus Good to know. We like testing these questions. It may not be on this exam. Again, it depends on, again, I have to go through and just make sure what I want to test for this exam and this exam specifically within the 70-minute time limit. Okay. But overall, this additional, if you really want to make sure that you are like set and covered, the additional practices are very good here. So these nested for loops that print out the following, these things. And then in 22, I mentioned Project Euler problem 1, as though you should know what that is. Well, you should know what it is, so I'm going to tell you what it is. Project Euler is one of the, so there are many different kind of websites that are available for you to help practice computing. One of them that's good for beginners is CodingBat. And this primarily focuses on Java, but they have a section for Python, which has a number of good things here to test. These are good kind of questions to practice on. For those of you who are taking this class because they wanted to learn Python, but they already know plenty of other stuff and they want to get really kind of get practice, I like PRAMP a lot. PRAMP is short for Practice Makes Perfect. And what this one is that this is peer-to-peer interviews. This one is for testing stuff that's a bit higher level, like data structures and algorithms. But if you know that kind of stuff already, this is good. And if you want to bookmark this for when you get to that level and are starting to do interviews for internships or actual jobs, this is a good website for that. Similarly, Advent of Code. This runs every year around Christmas, and it's kind of Christmas themed. It's kind of like you are a coder and only you can help the elves save Santa Claus and save Christmas. It's a lot of fun kind of things, and they are just different Christmas themed puzzles, coding puzzles. Project Euler is mathematicians. They do math problems that need to be solved by a computer. So let's see. And I've solved a number of these puzzles before I had to get on with other things. But what they are is that they'll give you a puzzle, and they will give you a box to check it in. So if you check it, it'll tell you whether you're right or wrong. If you get it wrong, you got to try to solve it again. And if it's right, it will open up a forum for you to discuss the answer with other people. You can do it in any language because, of course, these are math problems. Problem 1 is one of those ones that I use to really, that's good, that I use when I'm learning a new programming language to kind of make sure I understand the fundamentals. If we list all the natural numbers below 10 that are multiples of 3 or 5, natural numbers, by the way, for those of you who, haven't heard that term before, those are positive integers, so 1 and above. Natural numbers that below 10 that are multiples of 3 or 5, we get 3, 5, 6, and 9. Those are, the sum of these multiples is 23. Find the sum of all multiples of 3 or 5 below 1,000. So here's how it works for 10. Now do for 1,000. These are problems that are able to be done by hand. You can see how this would be very tedious if you wanted to do it by there. But this does get to a lot of things that are, but this really is a kind of useful way to do things. If we check problems 1 and 2 are pretty good. Problem 1 is especially very straightforward. Problem 2 less so. Problem 3 and 4 are where we kind of start getting a bit difficult. Prime factors. But these do get interesting. Some of these are easier than others, by the way, depending on your programming language. One of the things I love about Python is that it can do this problem like nobody's business. Work out the sum of the first 10 digits of the following 150-digit numbers. Python doesn't care. You just simply add these up. Put these in a file, read the file, add them up. Other programming languages like Java, however, have hard limits on what an integer can be. About 4 billion for an integer, and quite a bit longer for longs, which are 64-bit numbers, but they're not this long. And so Python, though, is still good practice for you because figuring out the first 10 digits, how do you do the first 10, just get only the first 10 digits from a computer program? And that's useful practice for you to get master the tool of modular arithmetic. But these are very good problems, and they get, and they get interesting. I use some of these for classes. I use this one as the last homework in my data structures class, a password derivation problem, where you're trying to basically figure out what somebody's password is based on key presses. And all that is it's a graph problem dressed up as a security question. Sudoku, one of those very fun ones. You've probably seen this puzzle before. Write a program that solves 50 of these suckers. And just does it. These are a lot of kind of fun puzzles that we can do there. So once we get to our exam, we will basically be hitting so what we're going to be doing is we're rapidly approaching the midway point of the semester. Now, when we get to the midway point of the semester, right, first off, you'll have lab 6, but then we'll have lab 7, which is the hurricane tracker. Hurricane tracker is where we're going to essentially, where we put all the basics of programming together. We put together functions, we put together the turtles that we use, we put together for loops, and we put together if statements, we put together file reading. We put that all together and we make something that actually you can show to people who ask you, what are you doing in programming class? You can show them and they're going to go, wow, that looks complicated. And then you're going to feel a bit embarrassed because you'll be like, it took me about anywhere, but it took me, and your answer will be like 20 minutes to 3 hours, depending on it took me 3 hours the first time to do it because I mixed up how latitude and longitude work for X and Y. That is where you will run into the most difficulty. And refer back to this lecture in case you get stuck there, because I guarantee that. Once we get there, we will learn about dictionaries, which are hard. Week 8 will be dictionaries, which are those extremely useful tools that are built into Python and other programming languages, but Python really likes using them. And problem 9 is where we get into math, and module 9, that's where we're going to be getting into math, and not the really scary math, but the fun math, where we talk about gambling and game shows and figuring out how that stuff works. Because again, even though this sounds Monte Carlo approximation, that sounds scary, the entire point about programming is to make your life easier. This is about saying statistics are hard, so rather than doing the statistics, I'm going to just play the game, but make my computer do it a whole lot. Okay. Relevant for the final exam, by the way, I should mention that turtles do show up on the final exam. Last semester, what I did is that we had 5 short problems and we had 5 large problems. You chose 3 of the 5 large, which 3 of the 5 large problems you wanted to do. So 5 small problems, each worth 5 points. And then you chose 3 problems, each worth 25 points. One of the possible choices was a turtle program, where basically you would analyze that and figure out what to do with that. So turtles will show up as a possibility on the final. I really like the way that worked out last semester. So turtles, even though we kind of stopped using them a bit after module 7, they do show up as an option on the final. So if you really want to hammer into them, you can. So that's all I have for you today. On Tuesday, that's when we meet. We will work on the Blame the Pope exercise, which is about leap years. So I will have to rename that instead of Thursday to that. On Thursday, we will go over the practice exam. If I need to make adjustments to the practice exam, I will send them out later. So just keep that in mind. And I will see you all. If you have questions or want a demo, come up. I will be prioritizing questions over demos.
Who was the other person you said we should know? The Alan Turk and the Ada Lovelace.
And Al Carl.
Okay.
Mohammed, if you can find, his Latinized name is Al-Ghamidi.
Okay,
And his book, and he wrote the book on algebra. So if you look, you know, this one, the compendious book on calculation by completion and balancing, that is all about that. Again, you don't have, I would, what I'm trying to say for this exam, know one of these three people.
okay. All right, thank you.
Mhm. Mhm.
So the Olympic symbol.
Okay, let me detach so that I'm not gonna suddenly make a huge FERPA violation by broadcasting everybody's grades onto this giant screen. I certainly haven't done that before and then noticed and
What radius do you want to get?
for radius.
Like the Olympic sign?
Oh, I don't mind. It just whatever shows up. Well, what's your last name, by the way?
Valentino.
Valentine. A fun one to say. Okay. And so of the five problems, what would you say the most difficult one to do was?
Honestly, probably this one.
Well, unfortunately, you aren't quite done with it yet.
Yeah, that's why, because it's
You,
like,
now you are for the most part, okay? And I'll give you half credit for what you have now on this one, and we can check the other ones and grade those appropriately.
Right.
So this would be 10 out of the 20 points. But what I definitely need most of all is for them to be colored appropriately.
oh, that's the problem.
Primarily, I mean, yes, I would like them to be a bit more, I mean, I think they need to do a bit more overlapping. I forget. I think they're overlapping fine. For the base credit.
Yeah, that's what I was.
They're overlapping fine for the base credit. Yeah, they're overlapping fine for the base credit. What I need is the colors
Oh, okay.
and make them a bit thicker if you don't mind.
Like the.
The width, the
Okay.
pen width. Oh,
Gotcha.
that's what you need to adjust.
Okay.
Pen width and color. Those are cosmetic things. So now let's go ahead and do the other ones. If you want to load up any of the stuff you draw, you can as well.
No, the second one. Oh, the green.
Okay.
Clock.
Look. Yeah, that one looks good. Next one.
Just with that, I'm holding everyone up.
It's fine. Everybody else is gonna hold everybody else
Yeah,
up.
I know. That's right.
Yeah, I get it. And again, this isn't the only time for students to do it. You can do it during lab. You can meet with me during office hours. Sometime that's not office hours. Next one. You lucked out because you have a very jagged
Yeah.
line. You can do yours with very jagged lines. Some people with like J's and D's, those for initials, they have a bit of a harder time.
This is the create shape.
Yep, and I want you to make hexagons because they're the bestagons.
Is that
Six. Yep. Cool. Yep, that's great. And then I think the last one is Triforce. Are you did it?
Yes.
Okay. And while that's going up, do you have Olympic rings going?
I have one left too.
A lab two. Okay, so go ahead and plug in appropriate numbers for that one then. Okay.
I fixed it last time. Last time we did additional numbers.
Okay. Oh, okay. So it's just that one, right? And I believe
I'll still need to do the for
you're good to go.
right.
Last name?
Clark.
Gracie.
Yep.
Yep, okay, and yep,
So I got half extra credit, you said, and then.
I get, so you've got a total of 90 on that because you've got the rest. You got 20 points for each of the other parts, and then you got 10 points for the one for the Olympics.
So I just change color.
Just change the color, resubmit it, you'll get your 10 points. Okay, that looks good.
Okay, and then for the messy one.
So I don't have to come to you to demo it again?
Nope, just submit it. Well, just submit it and like, let me know. You can either do that like an image or you can show your TA.
Thank you.
I'll make a note of it.
And then I just fixed that one.
Okay, great. And
Then the Celsius.
yep, 37 degrees, if you don't mind. Yeah, I was worried today was a bit too boring because, I mean, again, this is one of those days where I do have to like do the boring pedagogical stuff of check in with the class and see, you know. Yes, that is good. Yes, that 01 is something that happens.
Yeah,
That's fine.
okay. And this one in class, I was like, I don't get it at all, but it was kind of satisfying because when I was working on it, do you have a specific number?
5,000, that's the one we test generally.
When I was working on it, it like kind of clicked for me and I was pretty excited.
Yeah, this one is great because it really forces you to use that modular arithmetic, and it does take sometimes. It does take multiple approaches sometimes to get
Mhm.
something. It's amazing how, like, even sleeping on something
Yeah.
and coming back to it the next day is great.
And could you post the information about the hackathon?
I
Or do you have the information?
posted
about
it on Discord.
Okay, yeah,
um,
on there.
Yeah, so the Discord, I posted it in general.
Okay,
Let me go ahead and repost that
Okay.
it's on owlhacks.com. That is the website for the hackathon.
okay.
And I will just, I'll just say reposting. Okay,
Alright.
and there we go. So
Am I
now,
good for
yep.
the lab? All right, thank you.
already checked you off. Yes.
Alright.
Hi
Oh,
there.
this is for lab 3.
Okay, yeah, and I see you've got your Olympics for the regular credit. That's
Mhm.
good. It's very nice.
This one is the initial.
Mhm,
Um,
mhm.
This
Mm,
one?
Yep, got you. And I've looked up your name. So you're good to go.
Okay, thank you. This one is one of the electronic course.
Nice.
This one is the picking the sign or is it
Six,
six?
six-sided. And then,
This is the last one, the font.
yep, there you go. And so just remember to submit it, but you're good to go.
All right, thank you.
I just redid my big range of college for marks.
Valentino.
Marks.
Marks. Wait, the person who was just here? No, you're not the person that's here.
And I tried to make it overlap in the right way, but it's kind of hard. So like that one goes over, but you can kind of see.
Yeah, I can see it. That's good. Okay, and that brings you up to 110. And you're good to go.
Thank you.
Uh-huh. Cool. I was actually just seeing if I could see your last name and your username. So
Oh,
some people,
it's Q, it's
Mhm.
the Q, yeah.
Yep.
No. Can we do it again?
nope, that's good. Okay, okay, and
I was not sure about this one.
hey, that works.
All right.
If I can read it, it works.
All right. Yeah.
That is what it comes down to. I like the wallpaper, very powerful.
Thank you. Oh,
Oh, it's just waiting for the input. And your,
oh,
yeah, so it's asking for 6 there.
6.
Yeah. Mac makes it seem like it's freezing up
Yeah.
when it's doing that. It's very weird. It's very disconcerting. Okay.
Okay.
Yeah. Two more. Yeah, don't worry, we'll have time to get you.
Hang on.
Yep, you're good to go.
All right, thank you.
All right, and what's your last name? Yes. Um,
I'm demo both lab 1 and 2.
mhm. Yeah, sure.
Lab 1.
Great.
Like
What's your first name, by the way? I'm sorry.
Jia Hao. JIA.
Yeah, okay, I got it. No, there were two LIUs, so there were two. So I just wanted to make sure I got.
Let me use my the chocolate part.
Mhm. Mhm.
Judge the random number.
Yep. More ones that, are realistic, but I did like your, I did like the cat, by the way.
It's really simple.
Simple is good sometimes.
Now,
Yep. Mhm. There we go. Mhm.
I wonder what I had before.
13.
I put in 15.
That's good.
Alright.
And now, let's see. Do you still have to do temperature?
Temperature.
Yep. Yep, and yeah, so 37 degrees in Celsius. Yep, that's a good. Yep, it's just body temperature to body temperature. And then,
Second island.
yep, 5,000 is good, or three, whatever number, it's just thousands. Yep, that's good. And you're all good to go. Okay, so any questions otherwise?
Yeah, so, I have my lab on Fridays.
Yes.
Right now, I don't see my, I don't see the lab 30 minutes, so,
Interesting. It should be there.
well, at least on calendar, like on the calendar, it's in,
Did I not put in a due date for it? Let me check. No, I should put it, I put in a due date. It should be there.
I'm looking at that sign.
Okay, scroll down. That's assignments. Oh, from this one.
Is this one?
Yeah.
Oh,
Yeah, it should be, it's something that I think should have been done.
it's the Olympics one.
Yeah,
Alright, alright.
yeah.
Okay.
I mean, when in doubt, just go to the module pages and they're always going to be listed right here.
Oh, okay. Alright, thank you.
Yeah, no problem.
Alright.